Right. There's not a lot of hard data on how flex and fix ear types do in dry environments. Those designations were very much developed by corn companies in Iowa, in Illinois, in Indiana, in Ohio, where they're at a baseline planting at 30,000 corn plants per acre. And when they talk about pushing plants population, they might be going up to 40,000. So for them, there is, I would say, a lot of potential benefit to picking the right flex or fix type in that very wet, very high yielding environment where they're also growing 300 bushel corn typically. But Western North Dakota, we're not that. Not because we're not good farmers, but because it just doesn't rain sometimes, or a lot of the times. And and so the seed companies haven't spent a lot of time really developing the whole flex versus fixed types for semi-arid environments. And so, again, a part of this project was to just look at that. And granted, it's a small sample of the market. As Kayla mentioned, we had Channel and Proseed. Thank you very much to those companies that donated seed for us to use. And so this, I consider it with the flex and the fix. We're just starting to see what do we actually see in small plot results with flex versus fixed types in semi-arid environments, because we just haven't been doing that much.
Yeah, absolutely. No, and that's a big thing, is that there isn't a ton of work out there on the flex and the fix. And if there's one thing that we learned by looking close at those ear types, is that there needs to be a little bit more work on them. I didn't know too much about them either starting. A fixed ear type produces the same size cob regardless of planting population, which is exactly why those fixed ear hybrids, like Claire said, are planted more high moisture situations, higher planting population, because to increase the yield, you need more plants, more population. Whereas those flex ears are able to adjust ear size and the number of kernels in each cob, which is why they're commonly planted in those lower populations. But there's still not enough research out on those, not enough data to confidently explain the differences, at least what we could see in this area. In that image on your handout, there is a picture of flex ears. So we're able to see what's called reproductive plasticity, where the cobs are able to change their size and the number of kernels on each cob. So in those lower populations, 10, 14, 18, you can see that larger cob, and then it begins to taper off as population increases. Where there was more moderate, higher moisture in our trials, that's what we saw. But when we had droughted years, droughted environments, we didn't see as much of a tapering, as much of that plasticity. So absolutely room for more research on the ear type side of things. That could be its own project. That could be another 2 years if anyone wants to go into that instead. But as far as the planting populations and the economic side, which I had the most fun with, is kind of where I want to dive in next. So at the very bottom of that handout, you can see a table, which is Hettinger 2024 optimum corn seeding rate by partial profits. This was our partial budget analysis that we were able to put together after everything was harvested and we had analyzed the yields. We did this for each location, each year. We put together these analysis since there was such a strong environmental factor. Claire explained it great on that right side, explaining how Hettinger and Mandan in 2024, 2025 had just vastly different environments. But 24 in that figure, in that table on the bottom, where it was a dry year, we can see that 22,000 plants per acre is where yield began to plateau off. However, as you move across that table, we're able to see by the boxes that are found in those tables that are kind of laying over top of them, where the optimal range of populations are to that maximum return. So even though 22,000 was the highest yielding planting population, when the price was low around that $3, $3.50 per bushel, there was limited economic incentive to plant beyond 10,000 to 14,000 plants per acre. As the market improves and increases up to $4, all the way up to $5.5 per bushel, there was further incentive to increase that planting population up to that 22,000 plants per acre. So this same trend was seen across environments and all of the different site years that we had. But overall, that economic optimum and seeding rate really varied based on the environment and the current market price. Where it was more droughted, like we can see in Hettinger and like other site years had, it's absolutely valuable to plant at those lower planting populations, looking at around 14,000 to 22,000 plants per acre. If it's looking like moisture is going to improve, or if the market's going to increase, we saw higher moisture in 2025. If it's looking like moisture is going to be better, if the market's looking up, you could push it up to that 26,000 plants per acre, but again, very limited economic incentive to plant beyond that 26. So on a typical year, looking at about 14 to 22,000 plants per acre. So that was kind of the major takeaway, narrowing down where that economically optimum range is was a huge piece of this. And I just kind of want to end it. As Claire and I were finishing up this research, we had a lot of conversation about what future research could look like, especially for Western North Dakota and corn production. Obviously, expanding the population trials to a long-term study would be beneficial. This was only a 2-year study. 24 was dry, 25 was wet. We're looking at two very different sides of the spectrum, and so having a long-term study could be valuable. Incorporating predictive modeling to really see what spring moisture, just keep moving away. But predictive modeling with rainfall, looking at variable rate, fertilizer applications, since that's a really high expense as well for producers, thinking about some of these future research ideas. And I bring that up because at the end of the day, these research stations are for the producer. And so if there's something like this that you want to see more of, talk to Claire, talk to Chris, talk to John down in Hettinger. Those are the people that you need to be reaching out to because they want to solve your answers. You can talk to me. I'm just going to agree with you because I'm not even a grad student anymore, so I can only do so much. But yeah, but I am a local. I'm in town, so I just work at Rivera. So if you ever want to reach me, my cell, my email, or you can stop in. I'm not far away. So thank you all so much. If there's any questions.
And I'll just say, to keep the handout like as simple as possible, we didn't have all the yield from all the years, but just to maybe give you a little bit more data that we collected. So at Hettinger in 2024, it was really dry. It was quite dry. Our corn yield ranged from about 60 bushels to 80 bushels. Kayla did a very nice schematic of how dry Hettinger was, and Hettinger in 2024 was what? It was in the driest 25% of the past 30 years. So it was very dry. It wasn't like 1980s dry, but it was dry. Then you flip a switch, and in 2025, it was very wet. Hettinger in 2025 was the second wettest year out of 30 years. Mandan, it wasn't quite as extreme. So Mandan in 2024 was just slightly below average precipitation, but then in 2025 it was also very wet. I think it was like the third wettest out of 30 years. And because in 2024, so Hettinger, we kind of saw the yield response we were expecting. When we designed this project 3 years ago, I thought for sure we were going to max out corn yields at like 24,000 plants per acre, 26,000 plants per acre, and there's no need to put more than that in the ground because then you'll just get the classic plant response, right? Like you peak and then you overload the system and it goes down. I thought we would have gotten that curve, that's why we picked the numbers we did, but we didn't get that curve. In 2024, that dry conditions at Hettinger, we got the plateau. What? And we're running late. Sorry. Okay, so we'll wrap it up. Hettinger is real dry, in real dry conditions. 22,000 was our highest yield agronomically, but Kayla's box there shows us that the 95% of the time, your economic optimum was 10,000 to 22,000. So thinking about that really expensive corn seed, how much you want to put in the ground if it's a dry year, lower seed's probably the way to go. If it's real wet, the bonkers thing for me on this was that because we didn't crash the system like we were planning to, in 2025 we added on the extra populations of 34,000 and 38,000, so we put 38,000 plants per acre out there in Mandan, North Dakota, and it was super, super wet, and we didn't crash the system. We maxed out yields at about 180, but Kayla has that nice box, and if you want it, I can email it to you from her thesis. We got 185 bushels per acre at 30,000 plants per acre in Mandan, but the economic story was similar. Like, your economic best bet was going for a more moderate population, I think in the like 26 to 30,000 range, because seed is so expensive.
Thank you, Dr. Keene. Thank you, Kayla.